My friends, 1520, lab number 5, equilibrium constant. You write a balanced chemical reaction. It's very easy following simple procedures to write the expression for the equilibrium constant. Where did that value come from? So in this case, we're going to look at the determination of the equilibrium constant for the reaction between Fe3 plus and the thiocyanate ion, SCN minus, forming a one-to-one complex ion. What is the equilibrium constant? And we're going to do it by measuring the absorbance. You guys are coming from 1510, and so many of you have seen what absorbance is. It's really just color intensity, which is directly proportional to concentration, put in simple terms, that is. So if we measure or make a calibration graph for absorbance versus known concentrations, then we can use that to work or determine concentration for the amount. All right, so here is our colorimeter, color intensity measuring device. It's a simple one. It measures at 4 wavelengths. So the question is, which one do we use? So we'll actually determine which one by looking at the one that gives us the highest absorbance for a given concentration. Now, in this case, we want to do the calibration graph, which is absorbance versus non-concentration. Question is, we can't make concentrations of the complex ion Fe, SCN 2 plus. It's just not possible to do so. So we'll do kind of a clever thing here. We'll react the two of them in kind of one of them in very large excess. So if you look at this, this is 0.2 molar of the Fe3 plus. And then we're going to add to that 0.001 molar of the KSCN. What does that mean? It means then in this case, you have such a huge excess of one reagent that for all practical purposes, we can assume a complete reaction into the formation of the product. So how does this go? Got something like this, my friends. Put in, that's our cuvette, one of the round ones. Put in a in this case, water. And so just water here, which is our solvent in this particular case. You'll note that I'll put a little stir bar there. Now we've got to tell the instrument that this is our solvent. Please read this as 0. Read this as 0. So we do that by pressing this little button here. And then it goes, I'm considering this as 0. And then it gives us, there might be a little residue there. But so all 4 wavelengths add up as 0. So what I'm going to do is then remove that, get rid of the water. And because we're dealing with very small volumes here, and the residue volume in the cuvette, we call this a cuvette. Gotta do the language thing, right? And a residue in the cuvette might residue small volumes left inside might harm our measurements, throw them off a little bit. So I'm using a Chem wipe to dry it inside. Then of course, wipe it on the outside again. And then I'm gonna put in 4 milliliters. Pipette tip, put it in. That's 1 milliliter each. It calls for 4 of the 0.2 molar iron 3 plus.
Show the label.
Yep. All right. To the first resistance point, draw up the solution slowly. Put it in. 1, 2, 3, and 4. All right, I'll put that aside. Put my pipette aside, get the other pipette. That is now set at 0.1. So I'm going to be adding 0.1, 1.100 milliliters of the potassium thiocyanate. There you are, potassium thiocyanate. Let's add it. That's a small volume. Go down, take it up, small volume, put it in. Then I'm gonna stir with my stir bar. Close that. Turn that off. And I'm gonna look for the one that gives me the highest absorbance. Call that lambda max. And in this case it is, what's the wavelength here?
468 nanometer.
468 nanometers. My eyes are kind of weak. I've got to use my head here as eyes. So that's our absorbance then when we add 0.1 milliliters. And so we'll keep adding here until we add maybe 10, or when the absorbance kind of comes close to 2. Right, open that. That. Close that. Stay.
So after the second addition, the absorbance at 468 is 0.212.
The third addition, add it, close, stir, turn off stirrer, wait for values to stabilize.
So the third addition, it's going to be 0.383.
Fourth,
So the fourth addition, the absorbance is 0.550.
this is the fifth addition.
Absorbance is 0.694. 0.694. So the seventh edition.
Is it sixth or seventh?
Sixth. Yep.
Six. Some people can't count. That's
Yeah.
me. This is number 6, my friends.
The previous one was 5. So the absorbance value is 0.832.
Number 7.
The absorbance value is 0.962. That's the 8th edition.
Number 8.
So for number 8 edition, the absorbance value is 1.063.
And I'm just going to do one more here because it turns out my cuvette is getting full. Just one more.
So for 9th edition, the absorbance value is 0. Absorbance is 1.1. Skip switching. Let's go 1.195. Okay.